A warm welcome to all the students. Today we are going to see a very important chapter in Java, that is classes and objects. Although we have already seen what is a class and what is an object, today we shall dive into this topic into more details. So, let us quickly find out what are the contents of the classes. So, our classes, those who have come from C++ background, any class, a class has two different members. You have something called as class member variables, which are also called as instance variables, and class has something called as member functions. Also called as instance functions. Now, this is from C++. Now, in Java, these member variables or instance variables, we shall call them as fields, whereas the member functions we are going to call them as methods. So, a Java class basically contains two things. One is fields and the second thing is methods. Now, without wasting time, let us see how do we declare class. So, class declaration is like this. You start with class name, a keyword called as class, followed with the class name, then there is an optional keyword, extends and superclass. So, whatever I have written in square brackets, that is basically optional, and then you have a set of fields or set of methods, again they are optional. So, you have fields declaration, different instance variable declaration, and then you have something called as methods declaration. So, this is basically syntax of a class. People coming from C++ background should note that class declaration, it does not end with semicolon as it was in C++. Now, let us go ahead and see an example. Suppose we create a class called as rectangle, and it has two fields, let us say length and another field called as width. Now, students should note that these variables length and width, they are only declared yet. As of now, there is no storage space which is being allocated in the memory. When the memory will be allocated for this? When the classes will be instantiated, that means the object of the classes will be created, only then the memory space on the heap will be allocated. Now, as you all know that a class has fields or instance variables, it also has methods. So, let us quickly see the syntax of a methods of a class. So, you have data type, then you have method name, and then you have different parameters list, and finally, you have body of the method. So, this is syntax of declaration of method. Now, there are different parts. First, this is called as parameter list. Now many a times what happens is, in a function or in a method you may not give any inputs. So in that case parameter list can be blank. Method name, we know the convention of writing method names. Okay, method name should start with a small letter and then subsequent word in that particular name, its first alphabet should be a capital letter and so on. Third is a type. Okay, so this is second one. Third is a type. Type specifies the return type. The method may execute certain things in the method body, and at the end it might return something to the main function. So this is basically the return type. If the method is not returning anything, then the keyword over here should be void. That means if a method is not returning anything, then the return type of that method should be void. This is same as what we have studied in C++. And the fourth component of this method is basically the body of the method, where the code will be written. Okay. So now using this fields and using this methods, we can write programs. Okay. Let's say an example of this particular thing. So let us see an example of a class. I have my public class called as class demo. Okay. This particular main class, it houses public static void main function. So your actual program will be executed from void main, so it will be written here. Now since we are dealing with classes and objects, let me create a class called as rectangle. I create a class called as rectangle. Okay. And let's say this rectangle class, as you know, rectangle contains two parameters, that is length and width. So I will declare a double variable, say length, and another double variable called as width. So what I have done, I have declared two fields, one is length and the second field name is width, right. Now let's also declare a function called as, or method called as get data. So void get data. Please see the naming convention that I follow. Now this void get data function, it will do what is, it is basically going to get values for length and width attributes, right. So we will write this code after some time. Let us go. So let's say this is the rectangle class that I have created. It has two fields, one is length, one is width. So any rectangle will have some particular field value for length and some particular field value for width. And this get data function, later on I will modify this function so that it takes these values. Okay. Now from where these values will be taken, each object that is created of rectangle class, each object will have a different value for length and width. So it is basically the object that will be passing values to this get data function, right. So let us go ahead in the main public static void main and let us declare an object of type rectangle. So I will just say rectangle, say R1 and semicolon. Now notice that if you are coming from C++ background, you must be knowing that whenever I write this line in C++, rectangle R1, we say that R1 is an object that is created of type rectangle. So that much memory is allocated. However, in Java, okay, whenever I write this line rectangle R1, see that the object is not yet created. Okay, object is not yet created. This R1 happens to be just the reference name. It tells the interpreter that R1 is the reference name for a particular object that will be created in the heap. So R1 will be pointing to that particular object. Now actual object creation will happen now. So I say R1 equal to new rectangle, okay, and I will use R1 object name, and using dot, you know that whenever object is associated with dot operator allows the object to access the fields and the methods of the class to which it belongs. okay, provided those fields and those methods are public to it, that means it can access them, right. So using this object which I have created R1, okay, I use a dot operator and now I am going to call which function, which method, get data method, okay. So this get data method is called and the values I will be passing here. So this 3.0 and say 2.5 are the values of width, length and width which are passed. But now the question is, these values 3.0 and 2.5 which are passed, okay, they have to be stored in length and width. So first, whenever there is a call to get data function, the control passes from function call to function definition, right. So as we know that these are the actual parameters. Whenever we have a function call, the parameters which are passed to the function call, they are called as actual parameters. So whenever the call gets linked to the function code, okay, the actual parameters should be copied into the formal parameters. So I have to now declare some formal parameters that will copy this, in which these values 3.0 and 2.5 will be copied. So for that I declare double A and double B, two double variables A and B I have declared, okay. But now what will happen is R1, object R1 is going to call get data function and these two values are passed. So then 3.0 and 2.5 will be copied in A and B respectively, but these values which are now present in A and B, they have to be in turn copied in length and width. So I will now say the length equal to the value that is currently stored in A and width equal to the value that is currently stored in the B. So this is how by modifying this get data function, I have actually passed the values from the main function through the object call. I have passed these values 3.0 and 2.5 into the function called as get data, and within the get data function, or it is the get data function or method that accesses in turn length and width fields and it assigns the value to them, right. So this is how basically we can create an object, okay. Now next, once, okay, I will just expand this rectangle class now. We have already written one function or one method called as get data. Now let's calculate the area of the rectangle, okay. So now what I will do is I will take now the length and the width value, okay. I will take the values of length and width which are currently set to 3 and 2.5 in this particular function. It will calculate area and it will return the final answer, okay. Now since the final answer will be of the data type double, the return type of the function that I am now typing or writing is double. Since it is calculating area, I will just say rect area is the name of the function or the method. It will not take any parameters as arguments, and now I will just declare a variable, say area, okay, and I will say area equal to length into breadth, and at the end of this function I will return area, okay. So what rect area does? Rect area it declares a variable called as area, whatever, not breadth, whatever length and whatever width that we have specified, whatever length and whatever width that we have specified, it is going to multiply those and it is going to return. So this area variable should be also of type double. So it calculates length into width, stores it into area variable, and then it returns the area, okay. Now finally the program has to print the area, right. So what we will do is we will declare another variable called as result, okay. So we will say double result equal to, and now we will call this rect area function, okay. We will just call this rect area function, A capital here. You should be careful while writing the names, okay. It's a rect area function. Okay, how rect area function will be called? Directly though you cannot call, because rect area is basically a method of this rectangle class. So directly you cannot call that. So who can access these methods and fields? Only the object of type rectangle, and we already have R1 is the object of the rectangle class, and that's why it is R1 who will be accessing this rect area function using dot operator. Okay, R1 is small case. Fine. So then we can simply print system dot out dot println the area of the rectangle is and you can say plus, just print result. Okay. Now let's execute this program. So it calculates the area of the rectangle is 7.5, that is multiplication of 3 and 2.5. Okay. Now what has happened internally while writing this code? What has happened internally? That is what we are going to see now. Class demo is the main class. Okay. So it houses public static void main. First, the interpreter is going to see this line rectangle R1. Okay. So in the memory it is going to create a reference name for R1. So it creates R1, which is a reference name. Okay. It tells the interpreter R1, the statement tells the interpreter that R1 is a reference name that will point to an object of type rectangle. Fine. Next line is this line, where new operator is going to create a new object called as rectangle, and R1 will be it will be referencing that particular rectangle object. So graphically, new operator is going to create a rectangle object. Okay, it is going to create a rectangle object, and R1 will be referencing that rectangle object. So in a way you can simply say, okay, like how we used to say in C++, okay, what has happened is in the memory, that is heap area, okay, an object has been created and R1 is basically the name given to that particular object. But next question is, how much memory has been allocated to this particular object in the heap? Okay, so we have seen that class is basically a blueprint. Okay, class is basically a blueprint of the object that is created after that particular class. So the memory required for creating an object is equal to the memory that is required for storing the class data. Now class over here has two fields, one is length and width. Now data type double, it takes 8 bytes. Okay, so there are two 8-byte data types. So what will happen is in memory, the first 8 bytes, okay, will be reserved for length variable. Okay, then the remaining 8 bytes here will be reserved for width variable, and notice that length and width are nothing but the local copies of object R1. Length and width over here, they are the local copies of the object R1, right? So that's why basically when we refer to these fields, we call them as instance variables. Why? Because when objects of the classes are created, each object has its own copy of length and width variable. So if there are 10 objects created of rectangle class, each of these 10 objects will have their own personal copy for length and width. So you will have 10 different length variables, 10 different width variables inside every object. Okay. So and then the remaining memory here, Okay, it is allocated for what? For the methods. So, the very just by writing R1 equal to new rectangle, okay, just by writing this, what has happened in the memory? In the memory, an object has been created, and then R1 is actually now referencing that particular rectangle object, something like this. Now, further, R1 is now calling getData function, and 3.0 and 2.5 are passed as arguments. Now, there is another question. What if in this same program there was another object that we had created, say R2? That object also would have the similar attributes. Say first 8 bytes will be for length, and the next 8 bytes will be for width, and other area here will be for different methods. Okay. Now, you just see here, whenever getData function is called and 3.0 and 2.5 values are passed, okay, how the Java system will know whether the length should be 3.0 and width should be 2.5 of which object, whether it is for R1 object or whether it is for R2 object, how interpreter will find out. So, that is basically dependent on which is the object who is calling that particular method. Now, since R1 is the object who is calling getData method, okay, these values which we are supplying, and later on you see the definition of getData, the values are getting copied in length and width variable. Okay, it means that the length and width variable which are referred over here should be the localized copies of length and width which are there in R1. So, local copies of length and width in R1 are these, right. So, now let us see. So, getData function is called. Okay, so it is object R1 whose getData function is called, and the values 3.0 and 2.5 are passed as the arguments. Now, from here code gets linked to the call, this is called as function call gets linked to function code, okay, that is this getData function. Then when you come here, the function header, we notice that there are two variables which are declared, A and B. So, again in the memory there are two variables which are declared, one will be A, one will be B. Of course, these variables will not be part of the heap, okay, A and B, two variables are declared. Then 3.0 gets copied in A and 2.5 gets copied in B. So, A will get 3.0, B will get 2.5. Now, what is our aim? These values of A and B, we have to copy it in length and width. Okay. So, then what we are doing here is whatever is in A, that we are copied in length, whatever is in B, that we are copying in width. Okay. Since it is R1 who is calling getData function, this length and width must be, or which are, okay, the local copies of object R1. Okay. So, I am talking about this. So, this 3.0 will be now stored in length attribute of R1, and this 2.5 will be now stored in the width attribute of R1 only. Whereas, if at all there is another object in the same class that you have created, then its length and width variables will not get any values so far. They will get the values only when R2 is calling the getData function. Fine. So, at this moment what has happened in the memory is, in the memory object R1 has got its length and width value assigned. Now, further compiler now goes, the interpreter now goes to the next line. Okay. Now, this is a assignment statement. So, first the right hand side will be executed. So, it is R1 object who is going to call rectArea function. Okay. So, rectArea function is called. Now, rectArea function, what it does, it calculates area. Okay. So, who is calling rectArea function? It is R1 who is calling rectArea function. So, the length and width that we are referring over here must be the length and width which are present in R1 object only. So, it will multiply length and width. So, 3.5 and 2.5 will be multiplied, okay, and the answer will be stored in area variable. And what this rectArea function does is, it finally returns this area variable's value. Now, since the data type of area variable is double, the data type that is being returned is double, that is why return type also happens to be double over here. Now, the value that is returned, the answer that is returned after multiplication of length and width, which is area, okay, where it is copied. So, you go in the main, see it is R1 who has called rect area function. Now, this answer that is being returned, it has to be stored in something. So, result is a variable which is again of type double that we have created. So, it will evaluate this, and the answer that is returned, which is nothing but area in a double data type, that area will be stored in result. Okay, and finally, it is going to print the result and show us the area. Okay. So, this is basically how a class can be created and how that class objects can be created within the main and accessed. Right. Now, let us go further and let us see. Okay, let me modify this code. Okay, let me modify this code, and suppose I just declare a variable, say int x. Okay, if I declare a variable called as int x. Now, notice that in Java the variables or the member variables also, they are of different types. One, it is called as a instance variable. So, now here double length, double width, they are instance variables, because every object of this rectangle class, whichever object is created of the rectangle class, each object will have its localized copy of length and width. Okay, so they are instance variables. Why? Because they are associated with instance or objects. But whenever you declare variable within a method, that variable is called as a local variable. So, when I declare int x, the scope of this x is only till this opening and closing bracket of get data. Outside this, it does not have any meaning. So, x is called as a local variable. The variable that is being declared within the method is called as a local variable. Now, please note that a method cannot access local variable of other classes or methods. Okay. For example, if I just see the x is being declared here. Suppose I want to assign x equal to 10 in another method. Okay, it will give me error. It will tell me that it cannot find symbol called as x. Why? Because the scope of this x is limited to this brackets only, right? So, outside the get data method, x has got no significance, and that is why when you try to assign x in the second method, although both the methods are within the same class, it is going to give you error, right. So, this is an important thing that you need to remember. Now, let us go further and let us see, okay, how exactly the objects are created. Now, you see when I write here R1 equal to new rectangle, have you noticed that rectangle is a name of the class? Okay, rectangle is the name of the class, and after this rectangle there are closing brackets. Now, as per our knowledge, okay, what is the syntax of any method? We have already seen the syntax of any method is nothing but it is data type. Here it is the data type, then the method name and the parameter list. Now, if this particular method is to be called from say void main, then I will call it like this. I will use method name and then brackets, and maybe there are some parameters which I am going to pass in the bracket. So, this is basically called as call to a method. So, whenever you are calling a method, you reference it with the method name, and then you have this parenthesis for you to pass some input parameters. If at all, if there are no parameters, then also it is fine. You will be just keeping this particular field blank. But this kind of this format is for function call or method call. Now, if you notice carefully, whenever we create an object, okay, we use a similar syntax here. You write the class name and the bracket. So, this is basically nothing but it is called as constructor. Okay, constructor. Okay. So, what is basically a constructor? Constructor is nothing but its name is same as the class name. The first thing is constructors are automatically called when the object of that class are created. Very important. So, whenever object of any class is created, constructor is automatically called. Okay. So, what basically a constructor does is, constructor helps us to initialize or instantiate the object. Okay. The aim of constructor is to initialize the object, because every object will have some field values inside, right. So, if you want to initialize those field variables, constructor will do it automatically. Okay. Now, the second most important thing is the constructor, the name of the constructor is same as class name to which it belongs. Okay. And the third thing is, it does not return any values. Not even void. This is very important. So, constructor does not have a return type. Okay. And the fourth thing that which we have already seen in C++, that constructor should be made public. You cannot have private visibility label for constructors. Okay. This last point we will see later, but remember that constructor is nothing but it is like a method only, but only thing is that the name of the method is the same as the class name to which it belongs. Now, the normal methods which are there, or the member functions which are there, okay, you have to explicitly call that particular function. So, object has to explicitly call that particular method or function which is there within the class, whereas when it is constructor, it is automatically called, or it is automatically called when the very first object is created of that particular class, right. So, all this is very important for us to remember. Next is, there are different types of constructor. One, you have something called as a default constructor. Okay. So, this, as the name suggests, this constructor, even if you do not create any constructor, have I written any code here with the constructor? No, in this rectangle class I have only 2 fields and 2 methods, and both are normal methods. I have not created any constructor, but even though I have not created any constructor, there is one constructor which is automatically called when the object of that particular class is created, and that constructor is called as the default constructor. Okay. So, for our rectangle class, this will be the default constructor. Now, you just see in the body we are not doing anything, there is no code at all. Okay. So, this is called as a do nothing constructor, or it is also a default constructor. So, even though we do not write explicitly that particular constructor, it is Java which supplies this default constructor, and that is why whenever the object is created by the new operator, okay, how it is created? By calling the constructor. So, this is basically a call to the constructor, to the default constructor, which does not take any parameters and which also does not have any internal code inside. Okay. So, it is basically used to initialize the object once the object is created. So, when the object is created, like when R1 is created, its constructor is automatically called. So, even though you do not write a constructor, Java will supply a default constructor for this, and this is basically nothing but a call to that default constructor. That is the meaning of it. Okay. The second kind of constructor is called as a parameterized constructor. Now, as the name suggests, parameterized constructor is the one wherein you can pass parameters. For example, for our rectangle class, I can write this as name of the class. Okay, that's the constructor name, and I can pass some parameters. For example, I can pass some parameters here itself, that is 3.0 and 2.5. Correct? So, this is a call to the parameterized constructor. Okay. So, it is called as parameterized because it receives some parameters. Fine, it receives some parameters. So, I can just say int x comma int y. So, this is an example, and here there is a body of the constructor. So, this is an example of parameterized constructor wherein some arguments of constructor are passed through the main. Fine. So, this is a parameterized constructor. And third, we have a non-parameterized constructor, which is also called as default constructor. Only difference between this one and the first one is that the first one, this is do nothing constructor actually. This you don't have to write. So, even if you don't write any constructor, Java system is going to automatically supply this do nothing constructor, whereas this non-parameterized constructor will have some body, it will be doing something. It is not an empty constructor, it will be doing something. For example, whatever I did here by passing arguments, I could have done it in the body itself. So, I can write here rectangle, I do not pass any input parameters, but in the inside part I can declare those variables. I can say int x comma y and then the remaining part of the body. So, this is called as non-parameterized constructor. Fine. So, now what we will do is we will try to use one of these constructors, okay, in the rectangle program. So, here we have written this get data function. Now, the problem is it is object R1 who has to explicitly call this get data function, so that the length and width fields, they are initialized to some values, say 3.0 and 2.5. So, this is called an explicit call, right. So, now let me comment this, okay, I will comment this part. Let me comment this get data function, and instead I will supply a constructor. I will say rectangle, and whatever double values a and b that we have passed, I will pass it here. Correct? And then in the body of the constructor, I will write the same code that we wrote in get data function. So, length equal to this a and width equal to this b. Okay. And now, notice that I do not have to explicitly call this get data. So, I will comment it. Now, the problem is the constructor that I have created is a parameterized constructor. So, this constructor has two parameters, it is a parameterized constructor, but while calling or while creating an object, okay, I am not passing any values here. Okay. So, those values I can now pass, I can just say 3.0 comma 2.5. So, this is how a parameterized constructor is called. Okay. So, new operator, what it does, it basically helps us to create object, and when object is created, its constructor is automatically called. This is basically the call to a parameterized constructor where you are passing 3.0 and 2.5. So, you do not have to call this particular constructor, it is automatically called once the object is created. Okay. So, let us run the same program, and again the answer is same 7.5, that is length into width. Okay. So, this is a parameterized constructor. Now, we shall see a very important topic in object orientation, and that is called as method overloading. A very important concept, and that is called as method overloading. Okay. So, what is method overloading? So, Java, it makes it possible to have methods that have the same name but different parameter list and different definition. That means within the same class, okay, suppose the class it's a say rectangle is the class, okay, your class name is rectangle, and within this rectangle class you can have methods by name, let's say area, okay. So in one method can be int area, so this could be one method. Okay, you can have another method with the same name within the same class, say void area. Okay, then you can have another method, say void area, but this time internal parameters are different, say int x, int y, and this can go on. So notice that this particular concept was not there in C. If we are directly coming from C programming, you would realize that two functions cannot have the same name. But in C++ and in Java, basically in object orientation, there is a facility called as method overloading, where different methods or different functions within the same class can have the same name, provided either the return type is different, or the number of parameters which are passed are different, or the body is different, and so on. Okay. Now, when there are multiple such methods within the class, okay, it is called as method overloading. Similarly, you can have, since constructor is also regarded as a special kind of function, you can have multiple different constructors within the same class. In that case, it is called as constructor overloading. So what we will do is, since we are calculating the area, okay, here. So what I'll do, I'll create another constructor here, okay, say with the same name, rectangle, but it takes now no parameters, okay, and then if there are no parameters that are passed, then what it does, it simply assigns length equal to 5.8 and width equal to say 6.3. Fine. So this is one constructor, and so two constructors, and the third constructor which I am writing here, let's say it takes only one parameter. So I'll call that constructor, I'll write the definition of the constructor, I'm sorry, rectangle, it takes only one parameter, double, say m, and what it does internally, it assigns m, okay, you can n, it assigns m to the length as well as width. So you can just say length equal to width equal to m. So length and width, they are assigned the same values which are passed through m. So as you can see, this is one constructor, this is the first constructor which is parameterized constructor. This is a second constructor which is a non-parameterized constructor because I have not passed any parameters here, and third one is again a parameterized constructor. But although the names are same, at least the return type, I mean constructor does not have any return type, at least the number of arguments are different. So here there are two arguments which are supplied of type double, here there is no argument supplied, here there is only one argument supplied. You may write another constructor which takes say a different data type parameter as input and so on, okay. So but okay, now when you have this kind of multiple constructors with the same name in the class, okay, it is not going to generate any error or warning, okay. Now how in this case Java system understands which constructor is to be called, okay. So remember that when we call a method or a constructor in an object, what Java system does is it matches up the method name first, okay, and then the number and types of parameters. in order to decide which one of the definition out of many definitions which I have written have to be executed. And this particular property, it is nothing but it is called as polymorphism in Java, right. So, now you just see here, when the interpreter sees this particular code, it first tries to match the name rectangle, and it notices that there are three, in fact there are three constructors which are declared. But then it notices that okay, I am passing two parameters here and both are of type double. So, it will now choose that particular constructor over other constructor which has two parameters and both are of the type double. So, okay, so it will execute this particular code. Now, I create another object. Okay, if I just create another object, say R2, so I will just say rectangle R2 equal to new rectangle, and I don't pass any parameters. So, now what happens, when it sees this particular constructor call, it notices that okay, this particular call is for a constructor which does not have any parameters, right. So, it will call this particular constructor and length will be set to 5.8 and width will be set to 6.3, right. And then if you want to calculate the result, I will just change this from R1, I will make it to R2. So, it is R2 object who is now calling rect area function, and R2 object's values are length is 5.8 and width is 6.3. So, now the result of the calculation here will be different. Okay, you can just notice the result, it is 36.54, fine. So, this is basically called as constructor overloading, fine. So, basically this constructor overloading or method overloading is used when objects are required to perform similar tasks, but using different input parameters. Okay. So, we will take another example. Just to demonstrate okay, how method overloading works. This is constructor overloading, but suppose I was, instead of overloading a constructor, I was overloading a method. So, I will delete this part and I will now remove the get data function from the comments, and suppose I write another get data function, again say void get data. But this get data function, it takes only one parameter, say double, say p, and what it does internally is length, width both gets this value p. So, I will say length equal to width equal to p. Okay. I think I have written V capital. Okay. Void get data, I save it, and now I again use this get data function, but for the second object that is being created. Okay. So, the first object I am creating now using a default constructor. So, even if I do not write a constructor, Java will supply this default constructor and it will create my first object R1. Similarly, I have created second object R2. So, there are two objects which are created, rectangle R1 and rectangle R2. Now, R1 is calling get data function by supplying these two parameters. However, R2 is calling get data function, but the function gets only one parameter, that is say 2.0. Okay. Then I create another variable, say result 2 equal to R2 dot rect area Yes, and result 1 will be R1 dot rect area. Now, if you want to just print result 2, let us see what answer we get. Okay. We know that R2, object R2 is calling get data and it is only passing one parameter, that is 2.0. So, out of these two get data functions, which function will be linked? Okay, the Java system sees that only one parameter is supplied to get data function. So, out of many multiple functions which are there, methods which are there with the same name, it is only this method that should be called, because it has one parameter, that too of type double only. And then whatever value that is supplied, that is 2.0, okay, that is first stored in P, and then that 2.0 is copied in length as well as width. As a result, length is also 2, width is also 2, and 2 into 2 is 4. So, when you R2, this object R2 is calling rect area function, it comes here in rect area and it simply creates the multiplication of 2 into 2, and the area that is returned is 4, which is stored in result 2. So, I am trying to print now result 2. So, the answer of this is 2 into 2, 4. So, this is something a very important concept that is called as method overloading concept.